All right, so the last lecture we had this set of information, the universal set U, the subset A, subset B, subset C, and we're going to draw this in what's called a Venn diagram. So the Venn diagram looks something like this. And we have A, the circle here representing this set here. We have B representing this set here. And we have C representing this set here. We also have U, which is the universal set representing all of this. And so these diagrams are quite common in the work we're going to do in chapter 2, sections 3 and 4. Now, what we're going to do is we're going to fill it in with the elements, okay? So the first thing we find is the one in all three sets. If you remember right, last time that was the letter E. It was the only one in all three sets. And this set region right here in the middle represents the intersection of all three items. That letter E represents A intersect B intersect C, and there's one element in that intersection. Now, what we have, though, is the intersection between A and C, so the intersection of A and C, that is also just the letter E. So we've got it, the intersection of A and C is represented by that football-shaped item right there. All of the elements in that football-shaped item there are in both A and C. Now, we're going to move to A and B. So now we have the intersection of A and B. The intersection of A and B, we have the letters C, D, and E. C, D, and E. We saw that last lecture. So the letter E is already written down. We're going to add C and D in here because this football-shaped item right there represents the elements that are in both A and B. A and B, intersection. A and B, intersection. And E was already included in our set because it's in that middle quadrant there. Now let's take a look at B and C. So B intersects C. What is intersected there? We have E and F. E and F. The letters E and F are in both B and C. Now the letter E, that's this football-shaped item here, represents the intersection of B and C. We already have the letter E, so now we just need to include the letter F, which goes there. We put F here. It's in the intersection of B and C, but it is not in the intersection of A, B, and C. That middle piece represents the intersection of A, B, and C. This piece represents the intersection of B and C that are not in all three. So we write that one there. So that's all the inner circles, the inner quadrants there. We're now going to move out to elements that are just in A. Now, C, D, and E have already been written up here in A. See, this is A. This whole thing here is A. And C, D, and E have already been written. That means we just need to put A and B inside there. A and B, those two items, A and B, C, D, and E, A, B, C, D, E, all in A. Now we move to B. B has C, D, E, and F. C, D, E, and F. There are no elements that occur only in B that are not also in either A or C or both. And so we've already written all four elements in B. See this circle here, this big circle here, that's B, that represents B. And the four elements of B have already been included in these intersection pieces. And so now we move our attention to C. C has three elements, E, F, and G. E and F are written in C. See this big circle here represents C. Those two have already been written. What we have left over is the letter G. A, B, C, D, E, F, G. Now, that looks like we're done, but we're not done. Because there are also elements that occur in the universal set that are outside of these three sets. So they're in the universe of our overall elements, but are outside the three specific subsets, A, B, and C. And those elements are the letters H and I, and they should be written out here, H and I. These two letters are out here in the universal set that are not contained in A, B, or in C. So these are two elements that occur outside of that. And so now, as we write these out like this, we get a feel for the overall universe of these sets, this drawing, this Venn diagram capturing all of those elements. And so you can do this with just two items. If you only do A and B, the Venn diagram gets a little simpler. It looks simply like this. It just has two items in it. In which case, then this chart is A, B, and the universal set, and so you get a little simpler look, but it's the same idea. Is you look at A, you look at B. What items are in A that aren't in B? The answer is A and B are there, and then you have C, D, and E. C, D, and E, and then what atoms are in B that aren't in A? The letter F, and then out here in the universal you have G, H, and I. So if you only had sets A and B, you'd have a simpler Venn diagram that would look something like this. But if you have all three of these elements, you have a more complicated Venn diagram. You have a circle for representing A, you have a circle representing the set of B, you have a circle representing the set of C, and this whole Venn diagram representing the universal set U and all subsets A, B, and C in it. All right, so that's how these problems are done. You draw Venn diagrams, you put the elements in there, and then you'll ask questions. You might ask a question like, how many elements are there in all three? How many elements are just in A intersect B? And you have to look back at the Venn diagram, having constructed one, and then draw some conclusions from it. All right, that is the lecture for the Venn diagram, chapter 2, sections 3 and 4, and hopefully that helps you a little bit to understand the basic premises there, and you can start into the homework. There's also very good examples in in each section, and your professor, your lecturer will present you with some additional examples on top of that, and so hopefully this will get you going on this section. All right, we'll see you online. The online class is Friday, January 26th, and so we'll see you online for the next class. Not in the classroom, but online. All right, have a good one.